Hello, fourth grade. Today we're going to be doing a couple of lessons on line plots. You need to have your pencil and your book open to page 591 for the first lesson. Okay, now a line plot is when you organize your data onto a line and then you make a mark for each of the times that a particular number shows up in your data collection. Okay, let's look at the solvent share. Why don't we read it together on the count of 3? 1, 2, 3. Emily went fishing. She plotted the lengths of 12 fish caught on the line plot shown below. What was the length of the longest fish caught? What was the length of the shortest fish caught? Okay, and you're going to need to use our line plot in order to see this. Now, the first question they ask was, what is the length of the longest? Okay, so we're going to go to our line. You're going to look at the highest number on the line, but it also has to be a number that has a mark above it. A lot of times we'll use a dot above it. Also, some people, as you saw in the video before, will use an X. Okay, it was 8 2/4 inches. The second question they asked was, what is the shortest fish caught? Now you may look at the line and think, well, it was 6 because 6 is the smallest number on the line. But if you look closely, the 6 doesn't have a dot above it. It doesn't have an X above it. So that means they didn't catch any fish that were 6 inches. So the smallest number that has a mark above it is 6 1/4 inch. So questions that can be answered using your line plot would be, what is the largest fish? What is the shortest fish? You could also ask yourself, what is the most common length of fish caught? Which means, which of the numbers got the most fish? And that would be 8 1/4 because they caught 3 fish that were that length, and that was the one with the most marks or got the most votes. So there are a lot of questions that you can answer with your line plot. And again, it makes it a lot easier than looking at just a random list of numbers if you organize them to see which is the biggest, which is the smallest, and which is the most popular. Okay, let's turn and look at page 592. Again, your line plot shows the data organized on a number line. Each dot, or sometimes it's an X, above the point on the line represents one number in the data set. Now, if we look back at this, all the numbers were kind of grouped together. We didn't have any large gaps between them. However, if you have a line plot and you see that there's a group of numbers that all have dots or X's above them, and then way off to the side you see this other number by itself, that is an outlier. An outlier is any number in your data set that is very different from the rest of the numbers. It's not grouped close together with the other numbers, it's by itself. This table shows the distance Eli walked his dog each day for 7 days. So we recorded how far he walked on Sunday, Monday, so on for the rest of the week. And then he put it all organized into a line plot so you could see how often he walked certain amounts. For example, there were 3 days that he walked a mile. There was 1 day where he walked his dog a half a mile. But way over here, he got really ambitious one day and walked 3 miles with his dog. We have this gap between the next highest number, 1.5 miles to 3 miles. Because this one is off by itself, it's far away, we would consider that 3 to be an outlier. Let's turn to the next page. Let's go to numbers 3 and 6. Just a little bit. Okay. We're going to use this line plot to answer these questions. How many giraffes are 14 feet tall? We'll go to your 14, and how many marks to be put on the 14? There are 2, so that means we have 2 giraffes that are 14 feet tall. What is the most common height? So for that question, we need to see which of the numbers gets the most dots above it. And that would be 15. It has 3 dots. Nobody else has that much. So 15 feet is the height that appears the most often for the giraffe. how tall is the tallest giraffe? So what is the highest number that has dots above it? We go all the way to the right, and that is the number 18. So 18 feet is the height of the tallest giraffe. Then our last question, number 6, is there an outlier? Well, if we look, there's a little gap between 16 and 18, but it's only one missing number. That doesn't mean it's an outlier. That's not a big enough gap. They're all still grouped closely together. So the answer to that is no. There are no outliers. They're all grouped together. Say they are all maybe closely grouped. All the numbers in our data are closely grouped. Let's look at another line plot. Now for this line plot, it's the times that different people got on a 100-meter sprint. First of all, number 7 wants to know how many people ran in the 100-meter sprint. Well, to know how many people were running, we just count the number of dots we have on our line plot because each person has a dot that represents their time. So just count those up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So there were 20 people in all. Number 8, which time was the most common? So again, which time got the most votes, has the most dots? Look for your highest column of dots, and that of course belongs to 10 and 4/10. Of course, we're measuring this in seconds. Which of the times is an outlier? Remember, for an outlier, you look for a number all by itself, either towards the right or it can be towards the left too. And it looks like 11 seconds is way off by itself. So 11 seconds, because there's a pretty good gap between it and the next nearest number, would be our outlier. Number 10, how many more people ran 100 meters in 10 and 6/10 seconds than in 10 and 1/10 seconds? So 10 and 6/10 seconds, we have 1, 2, 3 people. 10 and 1/10, we have just one person. So the difference between those two is just a simple subtraction problem. 3 minus 1, so there'd be a difference of 2 people. 2 more people ran it in 10 and 6/10 seconds. And the last question, number 11. Curtis said more than half the people ran 100 meters in less than 10 and 4/10 seconds. Do you agree? Now remember, question number 7 said how many people ran, and we counted and there were 20 people. So for there to be more than half of the people who ran it in less than 10 and 4/10 seconds means there has to be more than 10 people who did that. Well, if we count the number of people who fell on this side of the line plot, less than 10 and 4/10, there is 1, 2, 3, 4, 5, 6, 7, 8. So Curtis is wrong. So no, I do not agree. Only 8 people ran in less than 10 and 4/10 seconds. Remember, we're not counting 10 and 4/10, just the times less, and that is not more than half of the people. We would need at least 11 people for it to be more than half. Okay, let's look to the next page and try just a couple more problems. Okay, number 12, here we have another line plot. This is the time that students spent completing a project. How many hours did they spend? Number 12, Mr. Dixon recorded the times it took students in his class to complete a project. How much time was most often needed to complete the project? So again, we want to know the most popular time. The most popular time is this one, 2 2/4 hours. Number 13, how many students are in Mr. Dixon's class? Remember, for that, we count up how many dots there are, because each student got to vote and gave their time. So however many dots there are, that's how many students there were. So there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 students in all. Okay, I want you to go to the bottom, and I would like for you to read and try number 16 and 17. Put the video on pause, and when you have the answers figured out, turn it back on to check. Okay, for number 16, it asks, which is an outlier? Well, if I look at this data, I see all of the dots are grouped together. There aren't any gaps. There's not one way off by itself. So the correct answer for number 16 was there was no outlier. Number 17. Which length of nail is most common? So which one has the most marks above it? And that would go to 1 2/4, option C.